So what should I include in the model? Should I include anything in the model if it has some sort of statistical significance? And we'll see that that's not the case. The idea is that I'm going to use past data to predict future returns. And let's just talk about this term data mining, because in some contexts, it's a reasonable thing to do. Essentially, it means searching for patterns or relationships in the data. And then I use the data to develop a theory as opposed to developing a theory and then seeing if the data supports the theory. And so data mining can often lead to an incorrect understanding of relationships. It's very common to use data mining in marketing because the idea is I want to see customer patterns and I want to see if a customer bought this, will a customer buy that, and what were customer decision processes like. But underlying this whole process is that I have a customer that is the same. And so I'm essentially applying these data analyses to a similar set of folks. The trouble is with securities returns, you can end up looking for and finding patterns in the data and then trying to make something up to have it fit, and you end up with some goofy stuff that we'll see in a minute. Just to talk briefly about some things that are very common to add in the data, as opposed to the Fama-French three-factor model, a fourth very common factor is something called the momentum factor. This is often referred to as the Carhart four-factor model, so it's the Fama-French plus momentum. Sometimes it's UMD or sometimes it's MOM, up minus down, and this is a portfolio of, just like small minus big is the return to a small stock portfolio minus the returns of a big stock portfolio. This is the returns of firms with the highest recent returns minus returns of firms with the lowest returns, because momentum seems to be a priced factor. Fama in French, there's the five-factor model, which is the Fama-French three-factor model. They add profitability, robust minus weak, which is firms that have very high operating profit minus firms that have a very low operating profit, and then conservative minus aggressive investment, and again, returns for firms that invest conservatively minus returns for firms that invest aggressively. Now, what this kind of has led to is lots and lots of people coming up with different, what they believe to be priced factors. And here's a paper written by Campbell Harvey et al. That looks at, well, called ... in the cross section of expected returns, a little bit making fun of some of the titles of these papers that came out. Lots and lots of papers that said, well, this explains returns and this explains returns and this explains returns. So what do we include? Well, it's a little bit tough to tell. I'm just going to look at couple of extreme examples of things that we probably shouldn't include. So here's a data set that I've been playing with for a while, and this is this sort of old folklore thing on Wall Street that if an AFC team wins the Super Bowl in January, February, then the market's down for the year. But if an NFC team wins the Super Bowl in January or February, then the market's up for the year. And so you set up a regression and you have a dummy variable for whether there's an NFC win or not. You run a regression and you get an R squared of 14%. Oh my God, I'm explaining 14% of stock returns just by looking at one data point. That's amazing. And I come down here and I can see that, yeah, it's not a huge relationship, but it is statistically significantly different from zero. Wow, if an NFC team wins the Super Bowl, the market is up, and if an AFC team wins the Super Bowl, the market's down. Why would that be? And people then have this sort of relationship, and then they try to make up some theory to fit the data. Well, NFC teams are in industrial towns, and when an NFC team wins, industrial workers feel better about themselves, they work harder, and productivity goes up and the market goes up. And of course, that's ridiculous. This is completely spurious. It's completely random relationship. There is nothing here apart from a spurious or random relationship between these two things. And just to sort of see what the data looks like, this is 2007 and 2013. It didn't quite work so well, but that's because we had this goofball year where the market was down a ton in 2008, and the Giants beat the Patriots. The Patriots were undefeated that year, so I'll just get rid of that data point, and oh look, there we go. I now have my statistical significance again. And in 2000 and 2016, the same thing. I wasn't getting a great relationship, so I'll just go back and change 2008, and then it's working. And here we are in 2019, and I'm not getting a very good relationship, but I got a couple of anomalous years that I really shouldn't be, including. And as soon as I either drop those years, I get a statistically strong relationship, or if I just change them, I get a statistically strong relationship. So the point is, of course, that the Super Bowl has nothing to do with whether or not the market is up or down. But if I run enough regressions with enough data on the right-hand side, I'm going to find something that explains returns that's statistically significant. And I should not include things unless I first have a reason for including them, and then from which I develop a theory, and then I test that theory by going to the data. And I shouldn't go the other way around. Just run regressions until I find something, and then try to think of a reason why it might be explaining returns. So the next thing I want to do is look at this paper, and this is on Canvas, so you can take a look at this. And it's called Stupid Data Miner Tricks. It was originally written in 1995 and then rewritten again or published again in 2000. And the idea is this. Back in the early 90s, pre-real internet days, the United Nations would produce a set of data which was the production of every single commodity in every single country, and they would put it on a CD and they'd stick it in university libraries. And so you had all this data on CD. And so what this professor did was he regressed the return on the S&P 500 with every single thing that was on these CDs, trying to find the best possible relationship. And let's see, what he found was the best fit for, the S&P 500 was butter in Bangladesh. And so butter production in Bangladesh, changes in butter production in Bangladesh, best fit the changes in the S&P 500. This produced the highest R squared. And so, of course, you should be sending analysts to Bangladesh in order to assess what the dairy cow quantities look like, so that you can then predict milk production, so that you can then predict butter production to best predict what's going to happen to the S&P 500. And the point is, of course, this is obviously spurious. There's obviously nothing here that you can just run regressions until you find something that fits, but there's absolutely nothing there. And let's just see if I can find this next one. As soon as he added butter production in Bangladesh and the United States and US cheese production, the R squared went to 99%. And so the point, of course, is that just adding right-hand side regressors that do have some sort of statistical relationship, all you're going to do is find things that are correlated but not economically related. You're just going to find spurious correlations.